Students, today I'll show you how to calculate the height of a distillation column. Now to find out the height of a distillation column is easy if the number of trays within the column are given. Now we are well acquainted with the McCabe-Thiele graphical method using which we can find out the number of stages in a distillation column. Now number of stages include all the trays within the column and also the reboiler at the bottom of the column and the partial condenser which is present at the top of the tower. The reasoning behind why a partial condenser and a reboiler they are considered as a theoretical stage, it's well known. Now it is very important that apart from the number of trays, because height of the column is directly linked with the number of trays, more number of trays the height of the column is going to be more, and if the number of trays are less the height is going to be less. Okay, now apart from the number of trays there are some special considerations which need to be taken into calculation. Apart from the number of trays, one important aspect is the fact that some additional space within the column needs to be provided for the piping which comes out of the reflux drum and enters into top of the distillation column on top tray. So some additional space is required at the very top of the tower, specially for the piping arrangement. Likewise, the feed when it enters into the distillation column, and the process should be as smooth as possible, some additional space around the feed tray should be given so that the piping arrangement is conveniently planted inside it. Okay, so some additional space at the top of the tower, some additional space around the feed plate, and importantly at the base or the bottom of the column some additional space must be provided at the designing process itself. The reason for that, the number one reason is the liquid hold up. It may be necessary when the capacity surges. Okay, when the capacity of the column surges, some additional space would be good so that the extra liquid can be held at the bottom of the tower. This is one of the reason. The second reason is liquid height in the base of the column must be high enough above the elevation of the bottom pump. Now you might be a little confused from where the bottom pump is coming in the diagram. See, when the different stream, whether it's a distillate stream or the bottom stream which comes out of the distillation column, okay, they need to be pumped out of the column to a storage tank or different part of the process plant. So obviously a pumping arrangement should be there. Now the point is that the positioning of the pump, okay, it may not be exactly on at the datum. Okay, it may be little higher. Okay, so the height of the liquid inside the column, for the bottom pump is to provide the necessary NPSH or the net positive suction head requirement for this pump. Okay, this is very important that the liquid height at the base of the column should be high enough above the elevation of the bottom pump to provide the necessary NPSH requirement for the pump. Okay, so for that reason some extra space may be necessary at the bottom of the pump. Okay, at the bottom of the tower. Okay, so a design heuristic is to provide an additional 20% space, okay, more than what is required just for the trays. Importantly, I must inform you that the spacing between the trays inside a distillation column is approximately 2 feet. Okay, or if you just convert it into meter, it is round about 0.61 meter. Okay, now if you need to find out the height of the tower, the formula should be H is equal to, since some extra additional 20% space is required, so for that reason, first of all, if the number of stages are n, to find out the exact number of trays, 2 has to be subtracted. One is for the reboiler, another one is for the partial condenser. So number of stages minus 2, okay, gives you the number of trays. So this is the trays. The spacing between the trays is round about 2 feet, okay, and because of the additional spacing which is required at the top of the tower for the piping arrangement around the feed plate, so that feed can be nicely introduced inside the column, and also at the bottom of the tower for additional surge capacity and providing the required NPSH or the net positive suction head for the pump at the bottom of the tower, 20% is prescribed, so should be multiplied by 1.2. Okay, so this should be the height of the distillation column in feet. If someone is more comfortable in meter, it is going to be 1.2 multiplied by n minus 2 multiplied by 0.61 meter. Okay, so tomorrow when you come across the distillation column and you can find out, you see the height of the tower, if you can guess the height of the tower, you can invariably figure out the number of trays inside the column. Or if someone practically gives you the number of trays inside the column using this simple formula, you can easily find out what should be the approximate length of the distillation tower. Thank you.